Hello, Heiko. This is the second part of bonus point 3, where I experimentally demonstrate the previous theoretical maths that I did, and also demonstrate how we can also apply to the same sort of maths to irregular triangles experimentally. So just a quick reminder. So at the end, my centre of mass was found out if we get vector b plus vector b over 3 plus vector h over 3, where b is vector b0 and h is vector. Here we have my right triangle, which we can see I've got height and base, and what I did is base is by third, height is by third, and then I've drawn my vector to the centre of maths. So if the maths is correct, hypothesize that the maths is correct, this will balance when picked up and will not flop to one side. It might not be perfectly balanced, and that's due to the limitation of the string. It's quite rigid and curly, and the material too, not evenly distributing the mass across it. It is just simple cardboard. And then this is my irregular triangle. Unlike a right triangle, we can't use the math I used previously, as that was for a right triangle. But what we can do is we can, as I demonstrated earlier, is with finding the centroid by drawing the corners to each midpoint, which I've done on my triangle here. And so again, when I pick these up, I should theoretically, it should balance. I've also done as a control, I've added a hole away from the center of mass to show that when picked up by the string, that it is not being supported by the string, the center of it, and it's not contributing, and that it will flop, and that we can see that this, when it's away from center of mass, that what it looks like. Okay, so I'll just set it up here, and we'll have a look-see. Alright, so we'll start with my right triangle. If we have a look here, you see when picked up and hanging on the string, that we get it considerably flat, considering it's a big piece of cardboard, and obviously when I let it go, we see it starts drooping a bit, but that's to the string and the control. So I'm keeping control of the experiment by picking both pieces of the string and allow it to freely move along it. As we can see here, I can push it up and it moves freely along the string. And we see it's balanced for the most part. Again, that's more towards the string than it is where it is. And next, we'll do my irregular triangle. Again, if we have a look here, triangle for the most part balanced and moving freely. So even when I shake it, it still finds its center of mass. And that's the same with my right triangle. Finds its center of mass. And I'll just demonstrate what it looks like without. So again, we can see here, when I move it off center of the mass, it's not laying flat. It droops down quite a bit, and holding the string taut, like the only reason it's not drooping more is it's actually, see if I push it up a bit, you can see it droops a lot more. The only reason it wasn't drooping more was it's actually hitting the knot. So that's off center of mass, just to demonstrate that we're not relying on the string to keep it up right. Alright, thank you.